All right. Good morning. Hope you guys had a great weekend. Thank you for being on time. I appreciate that. So we're gonna try to take that exam 3132 on Friday. The only problem with these two lessons, there's a lot involved in both lessons, 3.1 and 3.2. So in 3.1 we looked at exponential growth and decay. And my best advice to you, I just wrote the test this past weekend. Make sure you do the online problems. Okay, so make sure you practice the online problems so you know how to make a graph, you know how to input the answers correctly. Okay. Okay, so I am teaching a new lesson today in 3.3. The test will not be on 3.3. It's just 3.1, 3.2. And I did the things we've been going over. I really tried to focus on those problems, not the hardest problems in the world or anything. I did put the interest problem on there, but I took it out because I felt like it would take too much time. The continuous interest compounded continually, and I took it out. So don't worry about that problem. But you do have to worry, about the other sections. So you remember the problem that I did in class where we had 5 or 6 problems and you had to pick the right graph? Okay, that problem's on there. So that's like a 5 or 6 point problem where you have to, pick the right graph. And my recommendation to you is to actually graph it. Take like we did, take the function and graph it and then pick the graph. Don't try to just look at it and go, okay, it's this one, because that's really dangerous doing that. So just make sure on that problem that has the 5 or 6 different parts, just make sure you graph it and then you choose the correct graph. All right, so the first thing I'm going to do before I teach 3.3, I just want to take any questions you might have on 3.2. Now, I know that 3.2 is due tomorrow night, Tuesday. So I know it's due tomorrow. You should be just about done with it. Don't wait to the last minute to do the assignments, because what I really want today is maybe finish it up, and then I'm teaching a new lesson today, start on that assignment right away so it's fresh. Okay, so that's really what we need to be doing, because I'm giving you a lot of time to do the assignments. So you want to make sure you do them when I teach, start them right away and finish them up. Don't wait till the last minute, because it's like a waterfall effect of a downpour. It's not good. We really want you to work on 3.3 today. Okay. Anybody want to ask me any questions? Anybody want me to work a problem? I didn't do every single problem in 3.2. So if you have any questions, feel free, I can work them. So anybody want to ask me anybody want me to work any problems? I did not do a lot of the natural log, the ln, and I didn't do the base 10. So if you want me to work any of those problems, let me know. So just a reminder, remember that if you see this, you do not read that. Let me put myself. If you're wondering why I don't pin myself right away, I'm actually looking to see who's present, who has their camera on, and who's here. So if you're always wondering, why did she just pin herself at the beginning? All right. Okay, remember this, you're not going to read it as log of x. So this is log, this means log base 10. But you're never going to see it written like that. So just know that there's a 10 there. It's invisible, but it's there, log base 10 of x. And also this, you read that as that's an L, not an I, by the way. So that's a natural log of x. And what that means is log base E of x. Just see that written. So just make sure that you understand what these mean. Okay? All right. Anybody want me to work a problem from 3.2? Now remember that I didn't some of this like the book. So I really focused a lot on the properties, and I'm going to go over the properties of logarithms today in 3.3. So it's kind of like I already taught it, and now we're just going to integrate into that. So anybody want me to work any problem, graphing or evaluating, especially on page 464? I didn't do a lot of problems on page 460. Anybody want me to work any of those problems? No? Nobody wants me to work any?
Yeah, can you work problem 59?
59. G of x. I would make sure you know how to do this problem. Hint, hint, hint. Make sure you know how to do this problem. So it's log base 10 of x minus 1. Log base 10 of x minus 1. Let's read the directions. It says, this shows the parent use transformations to graph each function. So it says graph and give equations of the asymptotes and use your graphs to determine the domain range. Make sure you know how to do this problem. This is like a 5-point problem. So you know how to do it. All right. So I'm going to put, they want us to graph both of them. They want us to write the asymptotes of both, write the domain and range of both. Okay. So first of all, the parent, log base 10 of x. So we're going to do everything for the parent before we do this transformation, okay? All right. Don't work them at the same time. That's too confusing. So what points are you going to pick for the parent? What x's do you like? I told you there's 2 x's that you like. What?
Oh, so you have to pick points?
You have to pick x's to get the parent points. Remember how we parent points? We know it goes like this, but we got to go. Give me an x.
0.
Okay, we don't know anything about 0. So we know nothing about log base 10 of 0. So we know nothing about that. So this is a problem where we don't want to pick 0. Okay, remember we want log 1 because of the property. Remember log base 10 of 1 is 0. Remember that? Can't forget. So log base 10 of 1 is 0, right? So you're always going to pick 1. Give me another x. The base of a logarithm, right? Well, what's the base of the logarithm?
10.
So you're going to pick log base 10 of 10 to the 1 is what? What's log base 10 of 10 to the 1?
1.
Right. So you must know how this whole chapter is like this. So these are the parent points. Okay, who is the asymptote? Well, remember he's vertical, right? So it's 0. So they wanted the asymptote. They want us to graph it.
Hey, Ms. Birch,
Yeah.
where did you get the log base 10?
Okay, remember what I just said? That if you don't see anything written there, it's a base 10. So this is equal to log base 10 of x, but you're never going to see it written like that.
Oh, okay. Thank you.
So if you don't see anything, and it's 10. It's called a common logarithm. Draw your asymptote at x equals 0, and we know it's going up. So this is going to be right 1, 0. We go 2, 3, 4, 5, 6, 7, 8, 9, 10, and up 1. So it's like, how do we know what we're doing? See my little picture? See my picture? So you're going to run this up along the asymptote, and this goes up forever. This is a flat line, by the way, so it goes up forever. So let's just do the domain now. Ask for the domain and range. So what's the domain?
Zero to infinity.
Right. So it's from 0 to the right forever. What's the range?
Forever up and down.
And forever up. All right, is everybody cool with this? Now, if this had been log base 6, you put a 6 here. Yes? If this had been log base 12, you would have put a 12 here. So in other words, whatever the base is how you choose your second point, your second x. Understand what I'm saying or no? The parents are different. So I'm going to choose a different color. And now we're going to do this. Now is this, what is this? Is this A, B, K? Outside is A and K. Inside is B and H. What is that?
H.
Right. And what does this mean?
Right one.
Right. So what we do is we take our points and we add 1 to the x. Add 1 to the x. Y stay the same. So we can graph these. So you're going to go right 2, 0 and right 1. And now you draw your red graph along the asymptote along the black graph. I take it back. This is wrong. Hold on. This is because what's the new asymptote? Is the asymptote x equals 0 or did it change? Who moves the vertical asymptote?
The H.
Right. So shouldn't this be x is equal to 1? Before I draw this, shouldn't I draw an asymptote through x equals 1 and draw the graph along that? Right? So this guy runs along the asymptote x equals 0, the line. This graph runs along x equals 1 because the H moved him right 1, right? Okay, what's the domain of this guy, guys?
To infinity.
The domain is right 1 to infinity, so 1 to the right forever. And what's the range?
Forever up and down.
That's correct. Good job. Okay, now, like I said, this is worth about points. So make sure you know how to do this problem. All right, anybody want to ask me about it while it's up here? Go ahead, you can ask me. People get confused about this. So if you don't understand this, ask me. Go ahead, other questions? Okay, can I erase this? Bernie, Alex, Aiden,
Yes.
Yeah, I get that.
you guys okay?
Yeah.
You guys okay? Okay, would you like me to do anything else? Okay, last call. Anybody want me to work any problems? Okay, well, make sure that you have your questions ready on Wednesday and even Thursday because that'll be it. So you have questions for me when we're together like this, you should always have for me. That's really what this time is all about. All right, you ready for the new lesson then? We're going to talk about more properties. and there's 6 objectives. So let me just run them by you real quick. And we're going to look at the product rule, the quotient rule, the power rule. We're going to look at expanding and condensing, and we're also going to look at the change of base. So those are the 6 objectives. The first thing we're going to do is we're going to look at using the product rule. Now, remember what I said. This is not on the exam on Friday. This is a new lesson. This is not on the exam on Friday. So let me show you the rule. It says let B, M, and capital N be positive real numbers. So they can be fractions and decimals, but they have to be positive, no negatives. And it doesn't include 0 because 0 is neither positive or negative. It's in a class of its own. So let these variables be positive, real numbers, and B, that B cannot be 1. Here's the rule. Log base B of this product, now that means M times N, right? This means that you can write it as a sum. So check this out. They're saying if you have log base B of a product multiplication, M times N, right? You can make it a sum. So for example, if you have log base 4 of 7 times 5, if they ask you, what's expand mean? Can somebody tell me what does expand mean? Expand.
Like to go in depth or, okay.
Make bigger, right?
Yeah.
Good job, Bernie. Exactly. What does condense mean?
Make smaller.
Yes, make smaller. Good job. All right. So watch this. If they gave us this and said expand, we could use the product property and say this. Okay, because of the product property, we can write this as log base 4 of 7 plus log base 4 of 5. Right? Or vice versa. If they want us to make this smaller, we could go backwards. We could go forwards and backwards with this property. Watch this. If you were going to read this to me, you would say log base 10, right? So watch. Wouldn't this be log base 10 of 10 plus log base 10 of x? Look at this, look. Isn't this log base 10 of 10 to the 1? Isn't that the base matching the base of the exponent? So don't we know that log base 10 of 10 to the 1 is 1? You with me? Remember the property log base b of b to the x equals x? Well, isn't this log base 10 of 10 to the 1 equals 1? With me or no? So shouldn't we simplify it? Like, shouldn't we say log base 10 of 10 to the 1 is 1 plus log base 10 of x? Pretty easy, right? Okay, anybody have a question about the product rule? So when you have a product in a logarithm, you can make it a sum of 2 logs. So I'll say that again. When you have a product inside a logarithm, you can make it the sum of 2 logs with the same base. All right, you ready to look at the quotient rule? Okay, the quotient rule, it has the same conditions. I'm going to erase this. So the quotient rule says this, let B and M be positive real numbers. B cannot be 1. And this is objective 2. So check this out. This says if you have division M divided by N, guess what it's going to be? It's going to be subtraction of 2 logs. Watch. Log base B of M minus log base B of N. So the multiplication turns into the subtraction of 2 logs, and the division inside a logarithm turns into the subtraction of 2 logs. Okay, check this out. If they asked you to expand or use the property, what would you write? Log base 7 of what? Go ahead, I'm listening. Log base 7 of? Log base 7 of?
19.
19.
Minus log base 7 of?
X.
Yeah. Good. Okay, so look. So you look at this and go, okay, can I simplify this? 7 and 19? No. Can you simplify 7 and x? Because you always want to see if the bases match the base of the exponent. So this can't do anymore. So that's it. Okay, so here, look at, we have the natural log of square root of x. No, that's not it. I'm looking at the wrong problem. It's the natural log of e cubed divided by 7. How do you write this, guys? This would be the natural log, or log base e, of what? Right? Well, look at this. Doesn't this mean log base e of e cubed, right? So what do you have here? Can't you simplify this?
Wait, Ms. Bird, so that negative is part of the formula, right?
Yeah, the negative is part of the formula. See, when you have division, it changes to subtraction, right? It's part of the formula, right? So see how I have division? So I'm going to write subtraction. And now, look at, I'm asking you, look up here. Doesn't this mean log base e of e cubed? So what would that be?
3.
Right. So log base e of e cubed is 3 minus natural log of 7, right?
Wait, Ms. Bird,
Yes.
how did you do
Good.
that? It was an
Do it
E.
again. Okay, remember natural log means log base e. So natural log means log base e. So you'd have log base e of e cubed, and our inverse property says that when the base of the logarithm equals the base of the exponent, you get the exponent. Remember? Log base b of b to the x equals x. Remember that property?
Yeah.
So don't get confused. If you see a plain log, it's base 10. If you see a natural log, it's log base E. And we don't write all this stuff. I mean, you can, but I don't want to see it. Don't write it so I can see it. You just need to know that ln means log base E. By definition. All right, so this is the quotient rule. Okay, let's look at the power rule. So this is the third objective, and it's called the power rule. And this is the same, so I'm just going to erase this part. You guys okay so far? Can you guys respond, please? You guys all right?
Yeah, good.
Yeah.
Yeah.
Okay. So this is objective 3, and it's using the power rule. And this stays the same. Let B, M, and N be positive real numbers. B cannot be 1. And this is a cool one. Watch this. Log base B, that's a subscript, of M to the P. So there's 3 different levels. There's a subscript and a superscript and one that goes along with the log. You're never going to believe what this equals. You can bring the power in front and multiply to the logarithm. So can you believe that one? So the power property says that if you have this situation, you can bring the P in front of the log. I know that's crazy. That's just the way it is. So watch this. Log base 5 of 7 to the 4th. Well, isn't that in this form? Log base B of M to the P? So aren't I saying you can bring the 4 down and say 4 times log base 5 of 7? Yes or no?
Yeah.
Okay, let's do another one. How about a natural log? That's a no. Natural log is square root of x. Well, watch how I'm going to do the property. You have log base E of x to the 1/2, right? Because isn't square root 1/2? 1/2. So wouldn't this be 1/2 times the log base E of x? Yeah. Okay, one more problem. And then we're going to expand and condense. So we did all this so we could expand and condense. Check this out. Now, you have, well, pay attention. You have the power property, but you also have a product. So watch what I'm going to do, and you have to be careful. Watch this. I'm going to use the power property, because this is log base 10, right? Log base 10 of 4x to the 5th. So I'm going to put the 5 out in front. Now watch. When I use the product property, don't I have So isn't this going to be log base 10 of 4 plus log base 10 of x? And you see how I put it in parentheses because it has to be distributed? Don't mess it up. So this would be 5 times log base 10 of 4 plus 5 times log base 10 of x. And that is the answer if we were expanding. All right, so we're going to take those three rules right now, and we're going to expand and condense. So what three rules do we have? We have the product rule, which changes a product and a log to a sum or plus. We have the quotient rule, which changes the division in a log to the difference of logs, subtraction. And we have the power rule, which brings a power in the front being multiplied to the logarithm. And what you just saw me do here, you saw me do the power property, and then you saw me do the product property. Okay, now when I go through this, if you have any questions, make sure you ask me. So we've done 3 objectives. I actually think that you guys could actually ace this exam, this one that's coming up, this one here. But you gotta make, if you can't see it, you gotta ask me, but once you see it, it's so easy. So let me say it again. If you can see it, fine. If you can't see it, make sure you ask me, because this is probably the easiest test you're gonna take, this one here. In other words, you could really boost up your exam grade if you can understand this stuff. All right, so objective 4 is expanding logarithms. And you just got through telling me that expanding means make bigger, right? Or elaborate. So here's a problem. Just remember, we want to make this bigger. So we have log base b of x squared times the square root of y. All right, so the first thing we want to notice is you don't want to bring this power down because this power is not part of the square root. So we want to use the product property. So this would be log base b of x squared plus log base b of square root of y. So that's the product property, right? So now I'm going to use the power property. So the power property says I can bring this down in front, and I can write this guy as y to the 1/2 power and bring him down in front. So our final answer is going to be 2 log base b of x plus 1/2 log base b of y. Now you're going to be careful about your subscripts and what's in the logarithm, right? So does that look like we made this bigger? We made this bigger, right? Okay, questions about this problem? Let's do another one. This one's a little bit harder. So let's just talk this out for a minute. So first of all, we're gonna write this guy as an exponent, and we have a product on the bottom, and we have another power on the bottom. So it's like, what do we do first? And so what we're gonna do first, you guys, is you see that big old long bar? We're gonna do the quotient property first. So we're gonna get rid of that long bar. So the quotient property says we have log base 6 of cube root of x minus log base 6 of 36 to the 4. Right? Quotient property. So now I'm going to change this guy to log base 6 of x to the 1/3. And on the next step, I'm going to use the property, the power property, because we're expanding. What are we going to do there? Well, isn't that a product? And shouldn't I put this in parentheses? Because aren't you going to have to distribute the negative? So when you write this as a sum, right, you're going to have to distribute that negative, right? Right. So you have log base 6 of 36 minus log base 6 of y to the 4th. So we use the quotient rule. Now I'm using the product rule. Oh, shouldn't that be a plus? This should be a plus, right? Product rule. Yes. All right, so check this out. This is going to be the power rule 1/3 log times log base 6 of x. Watch this. Watch this. Isn't this minus log base 6 of 6 squared? Well, Miss Birch, why did you do that? Because see how I'm going to simplify it? Because isn't 6 squared 30? Aren't we supposed to be looking at special numbers? And then we're going to distribute the negative. So that's going to be a negative times a positive is a negative. And isn't this going to be 4 times log base 6 of y using the power property? So what do we have here? So we have, this is done. This one is going to be a -2 using the inverse property. And there's nothing more to do with this. And the question is, does that look like it was expanded? Does it look like it was made bigger from this? Yes, it does. Okay, now, anybody want to ask me a question about this one? So we use the quotient property. We're doing one thing at a time. Notice I have complete steps. Over here, I noticed we have the product property. I almost wrote a minus, but that should be a plus. But we do have to distribute the negative. We notice 36 is a special number. It's a square. So we wrote it as log base 6 of 6 squared, which is 2. So that's -2. And we use the power property on those guys. Okay, this is expanding using the properties.
Wait, Ms. Birch,
Any questions?
you
Go ahead.
turned 36 and a 6 squared, right?
Say again?
You turned that 36 and a 6 squared?
Yes. But you see why I did it though, Alex? I wrote it as 6 squared so I could use, remember when the base of the logarithm, when it equals the base of the exponent, we can cancel it? Remember that?
Yeah.
Yeah. Okay, just a reminder why you're doing all this, like why are you putting yourself through this? Because whether you go to UC or Cal State or Valley College or anything you ever do with any college, you're going to have to take a math class. And the math class you take, this one's going to help you out. So that's why you're taking good notes. That's why you're learning as much as you can, because the next time around is going to be so much easier because you struggled through this. So I promise you, I'm going to get phone calls like, Miss Birch, you were right. You know, maybe I didn't get a good grade in your class, but now I'm like the mathematician. I've had students actually become math teachers that didn't know one thing about math when they had me. So just keep reminding yourself, this is for the future. So you're putting yourself through this misery for the future. Because if you're gonna be a policeman, you have to take a math test. If you do anything, you're gonna have to take a math test. Even if you decide you're not gonna go to college, but if you take any college courses, you're gonna have to take a math class, and all this stuff's gonna help you out. All right, let's take a look at objective 5. Condensing logarithmic, so condensing logarithms. What's condensing mean? What's condensing mean?
Making something smaller?
Yep. And they're going to say something like, right is a single logarithm. Single means 1. So they're straight out telling you to do whatever it takes to write one logarithm. So check this out. Log base 4 of 2, we can't make a 2 look like a 4. Plus log base 4 of 32. All right, you ready? So now we're going to condense. You see that plus sign? Don't we want to use the product property? So can't we write this? They have the same base. So can't we write this as log base 4 of 2 times 32? Yes or no? So if we have a sum of logs with the same base, can't we write it as a product using the product rule? Yes, no? So would this be log base 4 of 64? Well, can't you make 64 look like a 4? Yes, no? Wouldn't this be 4 cubed? 4 times 4 is 16 times 4 is 64. So what's the answer?
3?
3.
So we did better than write a single log. We wrote a number. That's the best, right? So you see how by just understanding and using the properties, it's pretty easy. Like you might want to write the properties all on one page so you have them in front of you. And that way you could just use the sheet to do the problems. Let's do another one. This is log base 10 of 4x minus 3. Notice what I said, log base 10 minus log base 10 of x. Well, they're both base 10, so can I use the quotient property? This isn't a product, this is nothing. But can I use the quotient property where I write log base 10 of a quotient? Quotient means divide, right? So what do I write on the top? 4x minus 3. What do I write on the bottom? Can you cancel those x's? Can you cancel parts of a sum or a difference?
Yeah.
You can? Hold on a minute, hold on.
Why not? Because it's division.
If you have 2xy over y, you can cancel the y's because that's a product, right? But if you have 2 plus x over 2, can you cancel those 2's? See, you can cancel parts of a product, but you can't cancel those 2's. So if this had a 4 in it, you could cancel a 2, cancel a 2, cancel a 2. but you cannot cancel those 2's. So you cannot cancel those x's. You cannot cancel parts of a sum or difference unless there was a 4 in all 3 terms. So you're done. This is the answer. So let's look at one that has something like this: log base 10 of x plus 4 times log base 10 of x minus 1. Okay, now, you know these guys are powers, right? So you can't do the product property with these. See, the product property didn't show anything about powers. Didn't the product property just have logs? Didn't have numbers in front. So you can't use the product property. This doesn't fit the property right now. So watch. You're gonna make it look like the property, log base 10 of x to the 1/2 and raise the powers, plus log base 10 of x minus 1 to the 4th power. That's the product property backwards, right? Now use the product property. So that's the power property. Now we're using the product property, which says log base 10 of x to the 1/2 times x minus 1 to the 4th So I don't know, they might leave the answer like that, or they might write the answer like this. So that's leaving the rational exponent. That's changing the exponent to square root. So it's one of those two answers. I'm not sure which one they're going to use. And they might accept both. I don't know. So we use the power property to go backwards. And then we use the product property to write the product with one log. So remember that one log can be changed to two logs can be changed to one log using the quotient and product property. Let's do a couple more examples. Three times the natural log of x plus 7 minus natural log of x. Now, look at, you can't have that there to use the quotient property. You can't have that. So you have to make it a power. So remember, we're condensing. So this is going to be natural log of x plus 7 to the third power minus the natural log of x. Now use the quotient property. So the quotient property, we're going to take two logs and make them one log. And the quotient property says what? Take x plus 7 to the third power divided by x. And that's all you can do. All right, let's do a harder problem with condensing. So remember, when you're expanding, you're bringing the power out in front. When you're condensing, you're taking the power and putting them back up. Right? This is the power, right? I put them back up there. 4 times log base b of x minus 2 times log base b of 6 minus 1/2 times log base b of y. Now it's like, hold on a second. What are we doing? Let's not worry about it. We're condensing. Let's take the powers up. So this would be log base b of x to the 4th minus log base b of 6 squared, which is going to be 36, minus log base b of y to the 1/2, which is square root of y. Okay, and what are we going to do? We're just going to do, well, let me show you the easiest way to do this, okay? What I would do is I would leave this guy alone and use the quotient property here. So notice I put it in parentheses. This is a quotient property. So the quotient property says that I can write this as 1 log, and this is going to be 36 divided by square root of y. Follow that? And now I have the quotient property again. So it says log base b, 1 log, and this is going to be a quotient, x to the 4th over Okay, I'm going to do a trick here. I need you guys to pay attention. I'm going to do something here. I'm going to do something here to make this problem easier. Watch what I'm going to do. Check this out. If I put this in parentheses, wouldn't this be a plus? Because don't you have to distribute the negative if I put it in parentheses? Okay, let me ask you, isn't this equivalent to this? Because isn't this going to be a negative and isn't that going to be a negative? Aren't these equivalent when I put them in parentheses? So if you're wondering, why did I do that? Because I want to use the product property. I don't want to, did you notice that I was going to get a complex fraction? So if I put that in parentheses, I have the product property. So check this out. The product property says to write a logarithm and take the product 36 square root of 1. So that's why I did it, so I don't get a complex fraction. So now I'm going to do the quotient property. So the quotient property would be x to the 4th divided by 36 square root of y. And I know we're not supposed to have a y in the denominator, but we're not going to worry about simplifying it in these problems. We're just going to leave it like that. They asked us to condense, we condensed. And these should be parentheses, by the way. So this was tricky up here. What I did is I factored out a negative so I could write a sum. And the reason why I did that is so I could write a product, and then I wrote a quotient. So I did a little trick there to make the problem easier. And this is condensed, and this is correct. Okay, last but not least is the change of base, which this is really easy. This is called the change of base property. And I'm not even going to show you the property because it's confusing. I'm just going to show you how it works. So watch this. If you have log base 5 of 140, you cannot put that on the calculator. And you cannot make 140 look like a 5. So watch what I'm going to do. The change of base says I could do this. I could write this as log base 10 of the 140 divided by log base 10 of 5. So I could put it in the calculator. So your calculator is a base 10 calculator. And so we cannot do this by hand. We cannot get the answer. They're going to ask us to evaluate, which means get a number. And basically you need the change of base to do this. And so you always do this. You always change it to log base 10 of that number divided by log base 10. And you just have to remember, this number goes on the top, that number goes on the bottom. We're going to do a few of them. So can you guys find the log on the calculator? So find the log and put this in. There's 2 logs. So once again, we took 1 log and made it into 2. So anybody see the log? See it in the black over here? It's over here. See where it says log? That's base 10. So all you do is you go log base 10 of 140, parenthesis, divided by log base 10 of 5, parenthesis, and hit enter. What'd you get? About 3.07?
Yeah.
Okay, easy, right? So you're like, well, this is too good to be true. You know, what is she saying to us? Okay, let me show you. Watch this. You can't make a 5 look like a 3, right? Can't use a property. Can't do anything. You're completely stuck. Watch. You're going to change it to log base 10 of 5 divided by log base 10 of 3. And now I can use the calculator. So this is the change of base. We're changing the 3 to base 10 when we write 2 logs. And now we can use the calculator. So put this on the calculator, please. What's log base 10 of 5? Log base 10 of 5, parenthesis, divided by log base 10 of 3. What do you get?
Ms. Birch, can I see how it looks on your calculator real quick?
So the answer is about 1.465. Is that what you guys got or no?
Yeah.
So this is so easy, you might stumble over it. So don't stumble over it, okay? This is really easy. Let's do another one. Actually, you can put that in the calculator, never mind. There. That's log base 9 of 11. Can't put it in the calculator because you have a base 10 calculator. So how do you write the change of base, you guys? You write 2 logs that are base 10. What are you going to write? What are you going to put on the top? Go ahead, what do you put on the top?
11.
11.
Log base 10 of 11, what goes on the bottom?
9.
9.
Log base 10 of 9. And now we put it on the calculator. So this is called the change of base. So we say log base 10 of 11, close the parenthesis, or it won't work right, divided by log base 10 of 9, close the parenthesis. So it looks like, Bernie, is this what you have?
Yeah.
Okay, so hit enter. What'd you guys get? 1 point what?
1.09.
1.091, right? Or however they want you to round. So this is rounded 3 places to the right of the decimal. 1.09 would be rounded 2 places to the right of the decimal. Look at over here. 3 places would be 1.465. Rounded 2 places would be 1.47. That's it. That's the lesson. So 6 objectives. We went over the product rule, the quotient rule, the power rule, just in general. We looked at expanding by using those rules, which means make bigger the problem. We looked at condensing, which means make smaller. And we also looked at this is called the change of base property, because you can't do this by hand and you can't put it on a calculator. So you have to change the base to 10 so you can use the calculator. Pretty cool, right? Can you guys look on page 475, please? Okay, here's what I want you to do. We have 15 minutes. I want you to, you're going to go into your Math Wizard pair, teams, and you're just going to, you can start from the beginning and start on the assignment if you want, or you could just work different problems to make sure you know what you're doing with your partner. Okay, the main thing though is in 15 minutes, if you have any questions, make sure you ask me before you leave. All right? All right, I'll see you in your Math Wizard teams. I will be taking attendance in there. You guys want to ask me about anything? This is pretty easy, right? You just have to remember that this guy goes on the top and that guy goes on the bottom always. 2 logarithms, base 10. Okay, I'll see you in your teams. We're working on lesson 3.3 on page 475. 475.